In software quality assurance, we are taking certain question and answer. These are asked in interviews, in your exams. What do you mean by monkey testing in the context of quality assurance? So monkey testing, monkey. Now this is a concept. This is thought that a monkey, if something is given to this animal, then he or she will try everything. That is, this monkey testing is a black box testing, and this is employed to test the application by providing any kind of random inputs. So like a monkey, any kind of random inputs are given in order to check the system behavior, the software behavior, how it reacts, how it behaves. So we are basically checking the system, whether it is crashing, whether it is failing or not. So the main idea is to give random inputs in order to just find out it is crashing or not. So we don't need to create any kind of test cases here in this kind of testing. So it can be automated. Just write the program or a script, and that can generate any kind of random inputs, and that can be given to the software product or the system. So this technique is very much useful or employed when we are performing the stress test or a load test. So monkey testing, just randomly giving any input in order to find out whether the system crashes or not, especially in stress and load testing. So we can divide this monkey testing broadly into two categories. One is smart monkeys and the other one is dumb monkeys. So smart monkey is a little bit having an idea. Dumb monkey has no idea about the software product. Okay. So smart is somewhat smart. He's not all smart. But brilliant monkey is very smart. He knows everything. He has all the documents. He has all the inputs. He knows the results also. So we'll be discussing about dumb monkey and smart monkey. The first is the smart monkey, the middle one. Now smart monkey has a fair bit of idea about the software application or the product. So he knows that while he is testing the websites, for example, he knows which page he is going to visit after this one. So navigation, he knows that. He also knows that the values he is putting, the input he is giving is valid or invalid. Now if any error he finds, the monkey, then he is smart enough to find a bug or a defect or a problem that he can do. That means he knows the navigation, he knows the menus, he knows the buttons. So he has a fair bit of idea about the application. But dumb monkey, he has no idea. He has no whatsoever idea about the application. Okay. They don't know that which page he is, on which page he is going to go. So he doesn't know from where he is starting, where he is going to end. He is just randomly giving input anywhere, anytime, any kind of input. So they don't know about the application, but we know we want this kind of dumb monkeys. Why? Because most of the people who are working on the software later on, they will be like this. So they will try to find out, and these errors, environmental failure or the hardware failures, can only be found out when you act as a dumb monkey. So they don't know about the functionality, they don't know about the user interface of an application. This normally happens when a user uses it and when the company people who the stakeholders are going to use it. What do you mean by gorilla testing in the context of quality assurance? Now gorilla, the animal, or you can say a chimp. Now how he is known to us? He is known to us about ferocity, doing things with all valor. So gorilla testing, this strength is why we are calling it as a gorilla testing. So gorilla testing is a technique is a method of software testing in which very important is module. A module can be combination of classes, module can be even one class, module can be functions, module can be combination of functions. So a module, one module or a module is tested again and again. So some random inputs are being given and we are trying to find out the module's operation, checking it until we are satisfied there are no problems in the module. Okay, so we as a gorilla, we are just giving random input because he's a gorilla, he will give the random input, but he'll do it again and again and again. Why? On a single module. So we call it as a torture testing, we call it as a fault tolerance testing, we also call it as a frustrating testing. Okay, because of the pattern the gorilla testing behaves or it's worked upon. So this is a manual test. Please remember, not automated, this is a manual test and this is going again and again and again over, and this is done multiple times iteratively. So in gorilla testing, the testers and the developers, they work together. They do it just to ensure that or evaluate, determine the module's functionality through these all processes. Differentiate between gorilla testing and monkey testing. So there is a difference between a gorilla and a monkey as an animal. Same thing is applied here when we actually coin these kind of words. So gorilla testing is we are testing a module and we are trying to test the functionality, and here also in the like the monkey testing we give the random inputs. We are just trying to make sure that the module operation is fine. We are checking a module and there is no problems in the module. So gorilla testing is just testing a module again and again with random inputs. In monkey testing, this is also a method of software testing and we want to evaluate the behavior of the system. That is, here also we are giving the inputs, random inputs, but we are checking the behavior as the system or a software, it crashes or not. Because random inputs, there is no test cases we make here in the monkey testing and we are just checking that it crashes or not. So this is done on the whole system software. Gorilla is done for a module. Okay. Now the monkey testing, we can make test script, we can automate the process because it is all about giving the random inputs. In gorilla testing, the primary idea of this kind of testing is whether a function is working properly or not. Monkey testing is whether a system or a software is crashing or not. What is its behavior on random inputs? Gorilla testing is manual testing. Here the developer and the tester, they meet and they work together repeatedly. Monkey testing, this is kind of a random testing and it does not involve any kind of test cases, and any tester can do it. Gorilla testing, it is just testing few modules. We are not testing whole software or whole system, just modules. Monkey testing, we are testing the whole entire system, whole of the software. Okay. So module can be a group of classes or for even a one function or a group of function. So unit testing, what we do in the gorilla testing, because actually the testing of a component or a module is called unit testing only, done by the developer. Monkey testing is corresponding to the system testing. That is, whole of the software is made, any subsystem or any hardware or any kind of database is there, we combine and then we test for random input. So this is kind of a system testing, whereas gorilla testing is unit testing. There are different names of gorilla testing: torture testing, fault tolerance testing, frustrating testing. These are all a kind of gorilla testing. Monkey testing is also called as random testing, fuzz testing, stochastic testing. These are also the monkey testing only. If somebody asks you random testing, just answer monkey testing. differentiate between quality assurance and quality control. So quality assurance is a bigger set. It corresponds to a whole organization or whole institution, and these will be they will make the standard, the process, how to actually do the things, what has to be incorporated. Quality control is implementing these standards or the way which is being guided by the quality assurance. So quality control comes under, or it is a subset of quality assurance. So in order to implement quality assurance, we do quality control. This is the main difference. But let us see more differences. See, quality assurance is a bigger set. Inside this, there is quality control. And inside this, we have testing. So quality assurance is a method that focuses on assuring that a specified quality which is being decided or which is being proposed is being met. That this quality we are ensuring. And quality control are the method to achieve this quality which is set in quality assurance. So on achieving, this is focusing, quality control is focusing on achieving the desired level of quality. Quality assurance, the idea or the goal is how to avoid defects. Quality control is to find the errors and to correct them. Quality assurance is a way of keeping track of quality. So it's a kind of verification, you say. So verification, quality assurance, quality control is validation. That is, it's a method of verifying the quality. Until you do certain quality control work like the inspection, like all these, how can you ensure? So quality assurance, it does not involve the product itself. That is, you don't run the product or do the testing, etc. Quality control, you are actually running the software or the product for every kind of test. Quality assurance is a kind of proactive measure. That is, this is the method of prevention. The organization make a quality plan, they make the standards, they have the, say, quality assurance, the some standards they have, CMMI levels or ISO levels. And the quality control is a reactive measure. That is, something comes up, it is a remedial technique. That is how we control it at every juncture. Okay, that is how the testing comes under quality control. It is a part of quality control. Quality assurance, we are delivering to our users the quality product. And quality control is ensuring that the deliverables or the product are having that quality. So making it like quality standard meet, that can only be done using the quality control. Quality assurance is involved in entire software development process. Most of the time the quality plans are made way earlier in the SDLC. Quality control involved everywhere in the process, but mainly in the software testing or the hardware testing process. So quality control comes there because every time you need to check, inspect, and verify. So quality assurance is at the say organization level. So it establishes the standards and the processes in order to achieve the client expectation, what the user wants. So it is kind of ensuring that, okay, we are going to give you this. Quality control, while we are actually working on the product, it ensures that the standards being followed in quality assurance are being followed here. So quality assurance is a bigger set. It has to be done prior to quality control, and quality control is of course done after the QA is being established, and in order to implement that QA, QC is done. What do you understand about data-driven testing? So data-driven testing, this is a kind of software testing that store the test data. Just assume that we have a table. Table is just rows and column. It is a table or a spreadsheet. So now the data, which is a test data in the table or a spreadsheet, is the test data which is stored here. Now tester can do what? They can use this data driven testing to enter a single test script that can run tests for all test data from the table. So in a table, there are rows and columns. So you can just multiply a number of rows and columns and know how many values are there. Each of the value, a test script can be written. Each of the value can be the entry, and we can look for what is the result coming. What is the difference between the expected result and the actual result. This is also known as parameterized testing and table driven testing, because testers usually have several data sets for a single test. Here data driven testing becomes critical, because creating different tests for each data set can be very time consuming. So data driven testing allows data to be kept separate from the test script. So data is different, test script is different. Generally the tester do what? They have data and script together. So this is different now. And the same test script can be run for multiple combination of input test data. Just assume that we have multiple tables. Multiple tables have multiple data. So one input for the one input table gives result, other give result. So this is more efficient test result. So you see in the picture, here we have a data file. Data file means it's just like spreadsheet or table. So this test data, here you have a table here, multiple tables that contains your input data for testing. Now we have a driver or a script. You can just write a C program or just like that, okay, or in any automated tool. Now this data file is the input for this driver or a script, and this is given to the application under test, and here you get the actual output. In the data file, it is already there. Just let me show you a box here, a cell. So in this cell, you have the test input, you have the expected output, and then it comes the actual output. So here in one go, you know that what is the expected output, what is the actual output. So this is the beauty, this is the power of data driven testing framework. Rather than doing it all, use the driven test table. How do you ensure that your testing is thorough and comprehensive? Now testing never ends and it cannot be comprehensive. But only thing is you are transferring the testing from your end to the user end. When you are deploying or giving the software, you're actually giving him so that he finds out the bugs. Or you can say when the cost and the budget or the time it ends, the testing is over. But still, in order to answer this question, we have certain data structures, certain formats in our documents. The first one is RTM, Requirement Traceability Matrix. The second one is Test Coverage Matrix. So these both will assist us in finding or determining whether or not our test cases are adequately covered or fully covered, comprehensively covered. So the Requirement Traceability Matrix will assist in determining, we have a requirement specification. So whether the test conditions are sufficient to fulfill all the requirements which are given in your SRS, Software Requirement Specification. Now coming to the coverage matrix, this is going to assist us in determining whether the test cases are sufficient to satisfy all the requirement traceability matrix test conditions. That is the test condition which are given in the RTM, whether these test condition are the coverage is whole for that condition which is given in the RTM. So for the test TCM, the input is RTM. For RTM, the input is SRS. Okay. So this is how we can say we have done it comprehensively or thoroughly. This can be the only answer. What do you understand about regression testing? Which test cases should be selected for regression testing? Regression testing is all related with one word: change, modification. So regression testing, whenever you change, you will do the regression testing every time. That is why it's most expensive, most employed testing in the whole testing community or field. Maintenance time, 67% of the time we do maintenance, and most of the time we do the regression testing. So regression testing is a software testing technique when we change a program or there is a recent change or modification in the program or a code, now we need to ensure that it hasn't broken existing functionality. It has not created any more bugs. It has not created any more kind of defect. So regression testing is just a full or a partial. See, you can retest all. You have a test set, 100 test sets. So we can test all. You can prioritize. Oh, these 10 I will do. Or a regression test selection. 20 I have taken and I'll always do this in the regression test selection. Every time this 20 can change. So regression testing is just a full or partial execution of previously executed test cases. That is the test case set to confirm that the current functionality is working properly. There is no change because of the code modification. This testing ensures new code modification have not created unintended consequences for current functionality. So we want to ensure quality and functionality remains the same. So it ensures that old code continues to function after the most recent code modification. So what we see as for industry data, large portion of the defects reported by the customer, we just do it bug fixing. We just do the patching work. So that may create some inadvertent or unintended consequences, making selecting the test case for regression testing a very good art, not a very easy task. Okay, because that functionality has to be checked. So we have test scenarios that can be used to create effective regression test. The test scenario with high number of problems, defect or the flaws. Test cases covering features that are more visible to the user. Test cases that test the programs or products fundamental feature. Test cases of functionality that have experienced significant and recent changes or alteration. All test cases for integration, all complex test cases, and cases of boundary value tests. What do you understand about severity and priority of a defect in the context of quality assurance? Differentiate between them. So the word, if you know the meaning of severity and priority, that says it all. So a defect, how much severe it is, how much it is going to affect your software or functionality. Priority is what has to be done first, what has to be done later. So you know the problem, but severity, I'll tell you what are the levels just now. So severity is a metric. So the severity of a flaw or a problem or a bug is defined as the degree to which it can affect the software. Okay. So the severity is all about how much it is going to badly affect the software. So if I give a number 100 to defect, so if it is affecting 40% degree, so what is the severity? But if I give 80 to this 100, the severity is high as compared to 40. So the severity of a defect is a metric, is a number that indicate how serious it is and how much it is going to affect the software's functionality, software quality, and software status in the eyes of your users. Okay. So this is the severity. It's all about how much it is going to affect the functionality. Priority is a parameter, is a value or a way to determine which defect should be addressed in which order. If we have 10 defects, first we will do this, second, and then 10th we will do this. The higher priority defects should be addressed first. And these listing is only done with respect to the severity, of course. So severity of let us see the proper differences. The severity of a software defect or a flaw is a measure that indicate how serious it is, how seriously it is going to impact our software and software quality. Priority is a criteria used to determine which defects should be addressed first and which defects can be done later. Severity, the degree of severity, is directly proportional to the quality standard. If the severity of defect is higher, it is going to deteriorate the quality if you are not going to address it. There are certain flaws which may not impact quality as such. Priority is linked with the timetable for resolving the issue. First we will do this, the second you will do this, the 10th one will do last, like this. Okay. And mainly this listing will be done with respect to quality only. In severity, the defect severity level is determined by the testing engineer. The priority is generally defined by the product manager. Because severity is more related to quality, it is done by the testing one. The severity of a fault refers to how much it affects the functionality. So, as I said, the functionality of the software. So, the priority is just how quickly we are going to remove the defect, which needs to be fixed first, which can be done later. So severity, it has objective worth. I'll just tell you what it is. Priority, its worth is a matter of opinion. The project manager thinks, okay, this has to be done first, this has to be done later. But it has objective worth, means it is directly affecting the software. It can fail the software, severity is high. It is directly exposing the quality. Okay. So the priority may be on the user expectation. Oh, we have to do this, so let us do it first. Severity, see, severity can be performance issue. It can be that issue which is more important than any other functionality. Or the severity remains constant over time. If a flaw or a problem is severe, it will always be severe. It is less severe, it will always be less severe. The priority, see, I'll give an example of severity also. You know, in an aircraft, if a simple C code, if you know about the Boeing A370s or 350s, I guess, 2 or 3 aircraft, there was a nose up, fixing of a code. Okay. And because of the nose dive, many people, 400, 500 people died in different catastrophic accidents. So severity remains always constant. But priority changes. If user wants that 10th number has to be done first, it will be done first. It depends on all, about the way the software or function is working. The severity can be critical, major, moderate, minor, cosmetic. Let me tell again about the priority: low, medium, high. These are the levels.